Okay, well, welcome back to the shop, guys. I'm still on my buddy Stacy's 2021 Jayco Eagle travel trailer. We're going to turn into an off-grid home for him, and I had to make some room in the basement here. There's a front bedroom right here, and this is going to be the closet, and that wall right there went to right about there. It was just wasted space, so I'm trying to free up a lot more space in here to mount all the equipment we're going to be mounting, between the batteries, the inverters, DC to DC chargers, and of course all the electronics and wiring that has to go there. Finished putting the solar panels up on the roof there. That was a lot more work than I intended it to be, and it's not something I could probably recommend anybody try on their own, or at least to pay somebody, because that was crazy. And the next step is I have to figure out where I'm going to mount everything down here. It's all going to be boring. I'm going to have to make sure that it's mounted securely, because trailers are notorious for being very bad suspension. And while we might see it at the end, I said this was the closet up front right there, but this is where the washer and dryer is set up that he did add, and that's the drain plumbing and the freshwater plumbing for the washer on that side. So we can all assume that at some point this is going to get flooded or wet, so I have to make sure I don't put anything on the ground right here, especially with electronics, because I don't want them to get damaged, so I will have to set them up off the ground too. So rather than some long ordeal of me measuring everything out and tell you what I'm doing, let me just go ahead and build it, and then when I get ready to install the inverters, I'll tell you what's going on. And I think I've got all the rest of the fabrication put together. Now, wiring is kind of a boring video too, but I'll give you a brief overview of what we're doing. So Victron Energy doesn't have a multi-plus. It does 48 volt and have 2 line inputs for 50 amp service on it. What's going to happen here, now this Jayco Eagle is a 50 amp service. That means it has 2 line powers into it. It's easier to think of as a 100 amp service, but I know that electricians will be bothered by that, but it has 12,000 watts of actual available power to it. Now the Marine Corps or shore cord hookup would have gone right here. You can see a red, black, white, and ground. Now, red and black are the 2 line powers coming in with a common neutral right there. The line powers are technically, well, I don't know if you want to call it technically, but they're out of phase with each other. So each one of these inverters is going to handle each one of those line powers. So on the inverters here, we'll have like a red and neutral and a black and neutral. These are rated, I don't know if you see right there, it says 50 amp. So shore power comes straight into here. If you're plugged in, it'll come straight back out again and go inside to the very back of the trailer here, where the distribution box is, which is probably the worst case scenario for me, because most fifth wheels that we'd be doing this on would have had the distribution box right up here at the entry door where the stairs are, and the basement would have been right there too. Very easy to wire it up. So the shore power would come in, go to the inverter, go all the way back there, get distributed out. No big change from how the factory would have had it. Now we're going to install the batteries right here, so if we don't have shore power, the inverters themselves will just take battery power, and it'll be 48 volt, and turn it into 110 power, and then send it all the way back to the distribution box back there again. This is where it gets a lot more complicated and a lot more difficult for me. So I need to connect this shore power all the way to the inverters up here, and then run it all the way back to the kitchen or the galley there. Like I said, if this was a fifth wheel, that's not that big of a deal. I've seen lots of videos on fifth wheels where very simple to do because the distribution was right here in the basement area, but this is a travel trailer. I'm gonna make a executive decision right here, because that shore power from the Marine plug goes into the bathroom right here, goes into the basement, and that's where it goes all the way down the frame rail in the basement to the galley in the back. Now I am something of a frugal or lazy technician, so what I've actually decided to do is relocate the shore cord from the sidewall in the bathroom there, and I'm just going to go ahead and mount it on the sidewall at the front. Yes, I understand RV parks have the plug in the back, but Stacy's generally going to just be using this as a standalone off-grid cabin. He will have to likely get an extension cord if he goes to a number of parks. But that's not completely true, because sometimes the pedestal's right where my table saw is. All right, so if I'm relocating this over here, that means all I have to do is run only a couple feet of this 6'3" bundled wire from the sidewall there, from the front cap to the inverters. Simple job to do. But of course I still have to get from the inverters here all the way back to the galley. And I think what I can do on that is cheat a little bit. Now, because the factory already did run the 6'3" bundled wire from this point all the way back, that means I just need to get from the front tongue area right here, we'll call it about 10 feet back to the bathroom here, going underneath the RV. Should be a lot easier than all the way to the galley back there. So what I can do is just pop up through the floor here in the bathroom area, put a junction box, and then connect and splice in the existing wiring at this point. The last problem you guys might be aware of is, however unpopular it is to move the shore cord and marine hookup right there, I'll still have a great big opening right here where the old one was. And I'm a firm believer that a good looking intentional patch is always better than trying to hide something. So I have a switched utility light right here. And we've added some functionality to what was a hole in the wall. It's not going to be very fun to watch me pull wires, because I don't want to be pulling wires in my dirt right here, but that's how it's going to have to be. Hopefully we'll skip ahead to having the wiring done, and my frustrations won't be recorded. And then at that point we'll almost be in the home stretch of this job. Editing James from the future, yeah, we're nowhere close to being done with this job. I don't know what I was thinking, with most of the hard work done. So let's skip ahead. All right, so I'm in the bathroom, guys, and here's the update. Just wiring in the junction for the new shore power connection. Well, not shore power, but the new connection back to the breaker box in the galley. And maybe it's not the right application of these connectors, and these are very expensive, but I think that they do a better job of making a connection than a big wire nut does from the factory. And I've seen them stack lots of wires and something like that, and it has the antioxidant sort of goo in it already. All right, put the little caps back in. All right. Okay. So if you guys remember, the shore power was coming in at this point, going down into the frame down below to the load distribution panel underneath the galley sink there. So I took the marine cord hookup and I moved it up front here. So that's a 50 amp plug that goes in. It goes in right there to the inverters up there. But the existing wiring that's going back to the load center, I had to pull down the basement cover, right, and run another wire all the way to the front, right there. Bring it up through the floor. Yeah, I didn't add anything else other than that. That's Jayco's work. And it comes up out of the floor right there. Yeah, I should probably clean this up so we can talk a little bit better. All right, that's better. Let's see if I can explain and update you guys a little bit better now. Can you see me? Sorry about that. So the first thing to know about is the wire that we're using. It is the same 6'3" wire that the factory used when they wired up the shore power. It has 4 strands in it, just like any other RV with 50 amp service. So it's going to have a black, a red, a white, and then just a ground unshielded cable in it. Now, I'm not an electrician, but I'm going to try to explain kind of how it works really fast on 50 amp with an RV. The important things is we focus too much on amperage when wattage is the important thing, but amperage is how I think. It's also how things are labeled. So 50 amp service, look at that. So a 50 amp service from an RV, you have one common neutral, then you have a line power and a line power. With the exception of some really nice bus conversions or some high-end motor coaches, RVs are always running 120 volts. They generally never run 240 volts. But if you were to put the two line powers together, you have 50 amps, 240, which is 12,000 watts. I remember North America was first to market, I guess, with the electrical grid, so we did things weird. So the neutral, I'm not an electrician, splits the 240. It's kind of just supposed to be there as a return path to ground, and it can carry the balance of the load back to the main breaker box where it's bonded to the ground. That's not important. I hate getting into the weeds too much on this because electricity is still pretty much magic to me. So when these two are combined, you have one phase of 240. When you carry load through the neutral, you've split that phase up, and that's why we call it split phase. So you'll have 120 on this side, 120 on this side, and they share the neutral together. So strictly speaking, this is 50 amp service 240. But when I try to explain it to RVers, what we have is basically 50 amp, 120 on that line power, 50 amp, 120 on this line power. If you do the math, that's still only 12,000 watts, okay? So we haven't added any more power. I like to consider this 100 amps at 120 volts. But James, electricity flows in a circuit and you only have one return path. I know this, it's complicated. My mind works more effectively with direct current, where a circuit actually makes sense. But on AC, it's alternating current. It's going back and forth, and it's doing what's called a cycle, or a hertz. So this one phase of 240 is in 60 hertz. It goes 60 times a second, right? So what this does is this neutral carries the load from this, then it carries the load from this, then it carries the load from this. It switches back and forth, right? So at no given time is that neutral ever really carrying 100 amps. It's carrying half of the load, the other half of the load, half of the load, the other half of the load, faster than my mind can think or explain, and my numbers might be a little bit off. And of course, I don't want to get too pedantic about it because I don't understand it, but you have RMS, because this isn't a strictly on-off situation. So you have a ramp up, a ramp down, a ramp up, a ramp down, and maybe it's not 180 degrees separation on the two of them, so you might actually get a little bit of overlap on the neutral. Okay, hopefully I explained that enough that we can go to the next step. But that part will get us to how I wired up the inverters here and why I have two of them. The quick answer of why I have two of them is that Victron does not offer a multi+2 with 48 volts input and two line powers in with 35 to 45 amps out on each line power. They don't offer that yet, so I have to go with two. Ow. Now you guys have seen me install two inverters before on a 10,000 watt system, country coach before, but that was still 12 volt system, and they were 4,000 watts a piece. So this is a little bit different. Now the guys at Northern Arizona Wind and Solar, or NAZ, did recommend I go with the Midnite Solar Rosie, they were calling it. But like I alluded to earlier, I didn't want to mix and match systems more than I had to, because that didn't have a controller that would talk to the Victron controller for the charge controller. So I either had to mix and match, go all Midnite Solar, or do a hybrid system that was going to get even more complicated. And more importantly, the one inverter, that Rosie system, I think was still more expensive than the two Victron inverters. And Stacy really probably isn't going to be utilizing most of this all the time. His entire plan is to go north where it's not going to get hot very often during the summer, and come back down to the valley when it's not very hot during the winter. All right, so we got the shore power that comes in, and it comes out right there. People might not appreciate what I did here. I just didn't want another junction box and a whole set of connections if we didn't need it. So we have input right there, which is line 1, which is the black one in, and then we have neutral, and we have ground. You'll notice my neutrals aren't hooked up because I only have one neutral coming in, and I have to get neutral over to this one too. So what I'm doing is basically I'm going to connect all three of them right there, one going to this inverter, one going to that inverter. So that's just a connection right there that I'm putting inside of a junction or a component, so I didn't have to have a big utility box right there, just so I could make this connection inside a utility box. I hope everybody understood what I just said, because I'm not repeating it. So over here we have the red wire, that's line 2 input, and that neutral that's still not hooked up over here. So that's shore power coming into both the inverters, okay? Over here on the other side is line is AC out 1. I won't be using AC out 2, don't worry about that one. So we have line 2 power out, neutral out, and ground out. And then over here, line 1, neutral and power out. They're going to this junction box right here. And again, you can see the 3 neutrals aren't connected. So we have 1, 2, and then the third neutral, along with all the other ones, going through this connection or to the wiring right here that goes through the floor that I showed you in the bathroom there. So this is just the other end of that junction box in the bathroom, and then from that point it goes to the distribution panel in the galley. So hope everybody understands the shore power is coming straight in to both of these inverters and straight back out again if it's hooked up to power. If it's not hooked up to power, that's where the inverters will kick in, and we hook up battery power to this and turn into 110 power. All right, we don't have the same amount of capacity or wattage that the shore power will have, because we only have about 35 amps on each one, and so we're missing about 15 amps or 30 amps total when we're in inverter mode. But these do handle 50 amp transfer switch. That may not be an ideal situation for everybody's installation. We could have just put a transfer switch in right here that would have got rid of a lot of these connections. But that means whenever you're powering the inverters, the transfer switch has to engage and use power to engage that transfer switch. We'll be using it like a generator. But if we're trying to conserve power, holding the transfer switch closed the entire time does use power. Maybe not a lot of power, but it would add up over time. Or with the generator transfer switch, you're always burning fuel, so that doesn't really matter until you turn it off and the transfer switch disengages. Now, like I keep pointing out, these can handle the 50 amp load that will come from the shore power. So if you were to max out the load on the shore power, the transfer relays in here, not a very good diagram of it, can handle that 50 amp load. That's the update on how this has gone so far. I can tell you that best case scenario, if nothing goes wrong at all today, maybe I can get this thing finished, wired up, and installed and tested out. No misunderstanding. This is an incredible amount of work and not something that I would think most people would want to do. And it's an RV, and so you know nothing's ever going to go as according to plan, and there'll be problems. Now, if you've been following along, now you know that we have solar panels on the roof, the inverters mounted securely in the front compartment, but there's a lot of components that still have to be installed. We need a solar charge controller, wiring distribution, and on this setup, a DC to DC converter, and then we set up to program the whole thing. But I think it's time we should probably address the elephant in the room. Why are we going with a 48 volt system? I think it's important to acknowledge that I wanted to go 24 volt, but the customer decided that they've watched enough of the influencers out there that 48 volt is the only way to go. So that's why I wanted to go 48 volt. So let's talk about it real fast. What is the advantage of 48 volt? I don't like to touch on math too much because it starts to show my blind spot and my lack of understanding and clarity. As an RV technician, not an electrician, there's really only 2 laws or equations for electricity I know. One is Ohm's law and the other one is Watt's law. Now, Ohm's law always trips me up because in my mind, when you increase resistance, it feels like amperage would also increase, but I always feel like I get it backwards because when a bad connection happens, you get more resistance, which is more heat, which should be more amperage, or more current. But when I always try to do the math, it works out differently for me. So Ohm's law, very confusing to me. Terminology is all wrong because voltage is represented by a different letter, resistance is represented by a different letter, and amperage is represented by a different letter. It's very strange the letters they chose. But the Watt's law is the important one, and the one that I find very easy to remember because it's very intuitive to me. You have voltage times current or amperage equals wattage. Very, very simple. It's ironclad, and wattage pretty much is always wattage, whether it's DC or AC. So it's pretty simple for a simple mind like me. Now, of course, with all that being said, I, as an RV technician, very rarely have to worry about using any of this because the RV manufacturers do actually employ electrical engineers when they design these things. So the math is already done for me. I just have to match up the wiring that's already installed. And why do I talk about wiring? Because a wire, all it is a path for electricity to flow. There's a weird term called ampacity. It's just the amount of current a given conductor can carry before it starts to overheat, and the metal which makes it up begins to melt. And that's why we put circuit breakers and overcurrent protection on so that the melting doesn't start fires. So why am I talking about any of this? It's because this is the biggest advantage of 48 volt. By increasing the voltage, the wattage or power that the conductor can carry also increases. The current carrying capability of the conductor has not increased. We have merely decreased the amount of amperage we're pulling through the conductor. What it means is on a 12 volt system, you start needing to have 2, 3, 4-aught battery cable just to handle the same amount of watt loads that a 48 volt can handle with maybe, 6 gauge wiring. Now, besides the obvious weight and money savings between having to use a very expensive copper wiring, I think a nice thing about it is it's much easier to bend smaller diameter wire and route wiring than this big welding cable, 4-aught battery cable. Tangentially, that's why solar panels, you could have 2,000 watts up there at DC voltages being carried by these tiny little wires right here, or the standard MC4 type of wire gauge here, instead of having big battery cables, because solar panels do put out DC current. That's because they put out a much higher voltage. Like these are 42 volts. When we put them together, we have about 80 volts with the two of them together. We've already covered that. Some solar systems can be in the hundreds, like 250, 400 volts, carrying on that same tiny little diameter wire. And we don't have to worry about that wiring overheating because it's not carrying a lot of amperage. It just has a lot of voltage pressure. So between the weight savings, the money savings, and the ease of installation, that's why a lot of people are now going to 48 volt. I won't say that's the only reason why, but 48 volt is becoming a lot more common. There are some advantages of stepping from 48 volt to 120 volt that you don't have going from 12 volt to 120 volt when you invert. It's a little bit more efficient is my understanding. And of course, the inverters pretty much cost the same amount. There is some savings to be found also when it comes to some of the other components like the solar charge controller right here. When it comes to a 12 volt system, you might need 2 solar charge controllers to handle the amount of amperage or wattage that you want to do. Where with a 48 volt system, because the amperage is so much less, or the current so much less, you can get away with 1 to do the work of 2, and these can be quite spendy by themselves. Now, the last component that I need to cover when we're talking about an RV, and why I tried to talk Stacy into just sticking with 24 volt instead of 48 volt, is that there's not a simple way of getting 12 volt power from a 48 volt battery. And these RVs are wired for 12 volt. That's pretty much the entire systems are 12 volt with the exception of the ACs, the microwave, and the 110 outlets already. That's why you still have a 12 volt battery right there. On a 24 volt system, you're basically just putting 2 12 volts batteries in series. So it's easy to tap off of one of those batteries and you have a good 12 volt power supply for all the RV needs. But with a 48 volt system, unless you're putting 4 12 volt batteries together, it's going to be very difficult to find 12 volt, and that's why you'll need a DC to DC converter to go from 48 volt down to 12 volt. Now, I do hear what you guys are saying. It does have a 12 volt converter in it already. Very similar to this battery converter. Except on this one, it's hidden behind the load center down here. If we look at here, yeah, it's built into this right here. So it's built into here. That's why it's vented. So there it does have a built-in battery charger. We'll touch on that later. But it's important to remember that only works to charge the battery when it has 110 power. So that means you'll be inverting battery power to turn into battery power. It's very inefficient. And when you're off-gridding, you don't want to waste power because that was the whole purpose of this, right? So it's going to be much more efficient to go from battery power to battery power. So 48 volt to 12 volt. You don't have to do a lot of voltage loss in between going from battery 48 volt to 120 volt back to 120 volt back to 12 volt. And this is where it can get quite confusing because now we're going to have two sets of batteries because I can't completely eliminate that 12 volt battery on the tongue effectively. Between the 3 slide out rooms this has and the electrical power leveling jacks from Lippard, this is going to require a lot more than 30 amps to drive everything if you try to do everything at once. So in most normal situations, this DC to DC converter would work just fine because it maxes out at 30 amps. But if you had all the lights on inside and you're going to operate 2 slide outs or the jacks or whatever, those would overamp and kick this off and you'd lose all 12 volts. So I do still have to require keeping the 12 volt battery up here, mostly as a storage tank or a capacitor for the system. Otherwise, to do a battery complete deletion and replacement with electronics, we're gonna have to use 2 of these, and it starts getting pretty expensive and pretty confusing, whereas you can just get away with a cheap 12 volt battery, mostly as a filter and as a capacitor for the 12 volt system. I hope that explains everything that's going on right now and why I tried to steer away from any of these off-grid systems on an RV. But my friend wanted this. I'm trying to help him out. I would have preferred a 24 volt system. It's a halfway point between that 12 volt and the 48. Gives most of the advantages that you want. I won't deny the small little tiny gauges. It's going to be nice on the battery side. But other than that, it's a lot more confusing. And it did make me have to go find some 48 volt batteries. But that's going to have to be its own video because this is going to be a lot of information to dump. And I'm tired already. If I've confused you with everything else in this video, hold on to your hat because it's going to get a little bit more complicated and a lot more frustrating for me. So for all the electricians watching, I know it's not a 100 amp service, it's 50 amp service, it's single phase, there's no such thing as split phase, and I'm an idiot. All right, I got this word that Stacy is coming back finally. All the help that he promised to give me, he didn't really show up for that. He had awnings to do. There he is right now. Whoa, coming in hot. What you got there?
Yes, sir. This is Uber Eats.
Uber Eats.
Yes.
That's right. You got me food.
Jimmy John's.
Crazy fast.
Yes.
Well, thank you, Stacy.
You're welcome.
Is this your new toy?
Yes, sir.
So you don't even care about this trailer anymore then?
Yes, sir.
Oh, you do care about it?
I've got the 500-pound motorcycle receiver that goes in the back. Well, the ball mount that goes into the receiver. It's
all right.
In the back, so now it'll be even bigger, wider turns.
You know, you said you're going to help me do this, right?
Yes. I did help you, so let me know, because I like to work alone too. So I didn't want to bother you, because I know how I am.
All right. Well, thank you for the sandwiches.
You're welcome, brother.
So Ohm law is very confusing to me. It's what amperage times voltage equals so Ohm's law I found to be very confusing.